Hi students, this is your Shiva and you are watching Shiva's Maths Library. In this video we are going to solve the 7th question of our end of our chapter exercise. In this question, the question is use the method from problem 6 to check if the points are minus 5 comma minus 1, B minus 2 comma minus 5 and C 4 comma minus 2 are on the same straight line. Now plot the points and check your answer. Okay, so in the previous problem, sixth problem, they ask us to do the same thing. First we have to plot the points on the number line and we have to check whether they are located on the same line, and they asked about a different method, suggest some different method to check whether they are located on the same line, and the method that we followed is called the method of collinearity. So here we are going to use the same method to check whether these 3 points located on the same straight line. So what is the method of collinearity? The method of collinearity is nothing but the method of collinearity is nothing but we have to find the length of the 3 points. Suppose here we are having the point R, B and C. We need to find RB, BC and also RC. So out of the 3, sum of any 2 should be equal to the third one, should equal to the third side. Then we can say that the 3 points are collinear. Okay, so first let's start to find the distance of the 3 sides by using distance formula, that is nothing but x2 minus x1 the whole square plus y2 minus y1 the whole square. Here we can choose either x2 minus x1 or x1 minus x2, anyhow we will get the same answer. So let's start with RB, and you know the point R and B. The point R is minus 5 comma minus 1 and the point B is minus 2 comma minus 5. So x1 minus x2 it's going to be minus 5, and this minus of minus 2 it will be plus 2 plus minus 1, and same minus of minus 5 will be plus 5, which is equals to under root, this will be minus 3 square which is 9 plus this is minus 5 plus minus 1 plus 5, it's going to be 4 square which is 16, and this under root 25 which is equal to 5 units. So we found the distance of RB. Similarly the distance of BC, okay, and the point B is minus 2 comma minus 5 and the point C is 4 comma minus 12, and here minus 2 and this is minus 4 whole square, and here it's minus 5, minus of minus 12 will be plus 12. So it's going to be under root, this will be minus 2 minus 4 minus 6 and minus 6 whole square will be plus 36, and here it is minus 5 and plus 12 which is plus 7, and 7 square is 49. Okay, so this is going to be under root 49 plus 36, this is 55 and 85. Yeah, it's root 85. Okay, you can erase this. Okay, this root 85. Fine. Next, the third side, this BC, and the third one RC. Okay, and R point is minus 5 minus 1 and C is 4 comma minus 12. So minus 5 and minus 4 whole square, similarly minus 1 plus 12 the whole square, and this is going to be minus 9 square 81, and this is 11 square it's 121, and the answer is 82,202. Okay, so finally we found the value of RB, BC and RC. So RB value is 5 units and BC value is 85 and RC value is 202. Now the only thing we need to do is sum of any 2 sides should be equal to the third side. If you add the first 2, we won't get the third one. So first possibility is wrong. If we add second and third, we won't get the first answer, because root 85 and root 202 we can't able to add, and the answer is not going to be 5. Then first and third, so if you add 5 and 202 we won't get 85. So from the three answer we got, okay, any, or we can say like none of the sum of two sides is equal to the third side, because they ask us to check for any two sides. Here none of the sum of two sides is equal to the third side. This implies that the point R, B and C are not lies on the same line, Now we are going to check the same thing by, let's start to substitute the point in the graph and let's see whether they are forming a straight line or not. So let's start with our first point R. R is nothing but minus 5 comma minus 1, right? So x-axis minus 5 and y-axis it's minus 1. So x coordinate is minus 5 and y coordinate is minus 1. So the value is going to be here. This is our point R. Next one is B, which is nothing but minus 2 comma minus 5. So minus 2 comma minus 5 must be here, and this is our point B, and the point C is 4 comma minus 12. Yeah, 4 comma minus 12 it is. So 4 comma minus 12, it's somewhere here. This is our point C. Now let's check whether these 3 points located on the same line. Okay, let's connect our R and B, then we will extend and let's see whether no, I don't think they located on the same line. See here. Okay, so there is some, actually the point 3 comma, actually this point, the point 3 comma 12 may lies on the same line, but 4 comma 12 doesn't lies on the same line. So we are getting the same answer here. See, R, B and C, when I join all the 3 points with a straight line, the point C is located outside the point, outside the straight line. So these 3 lines are not collinear, so they are not collinear and not located on the same line, not on the same line. So this is our conclusion for the first question. And the second question is, using the origin as one vertex, plot the vertices of a right angled isosceles triangle. So this question is very easy, because they have given a origin as one of the vertex and they ask us to construct a triangle here. So we know that for a triangle we need 3 vertex. So one of the vertex is already given as a origin. So this is my vertex. I am assuming it as the vertex A. Now I need to construct a isosceles triangle, and also it should be right angled. Okay, for isosceles triangle we know that it two of its side has to be of equal length, and since it has to be a right angle triangle, I need to construct 2 sides of the triangle which are perpendicular to each other. Okay, since the point A is, that is the point A is our origin, I can take x-axis as one axis, one side, and y-axis as another side, so that it will form a right angle here, and also I can join this to get a right angle triangle. But one more thing is, it has to be an isosceles triangle, which means sides are of same length. So on my x-axis I am going to consider the unit as 5 unit. In the same 5 unit it has to be there on the y-axis, so that I can say that it is 2 sides of the triangle are of equal, so it has to be an isosceles triangle. So it has to be 5 units. It need not be 5, you can make it as 6, 7, 8 or 3, 4 also. Here I am taking the point B, which is 5 comma 0. X coordinate is 5, y coordinate is 0. Similarly on my y axis I am going to choose the point 5. Okay, choose the line here. Okay, and this point is C, which is nothing but 0 comma 5. Okay, so if you join these 2 points, obviously we are getting a right angled triangle which is 90 degree at the point A, and this side and this side are of equal length, 5 units. Yes, this is our required isosceles triangle. Similarly, you can take 6 and 6 here, and you will get the same answer, or 7 or 7 or 3 4 also. Okay, in the next question, an isosceles triangle with one vertex in quadrant 3 and another vertex is on quadrant 4. So we are having the same origin as our point A, and I need to select a point from quadrant 3 and another point from quadrant 4, and the triangle has to be isosceles triangle. It need not to be right angle, only isosceles triangle it has to satisfy, which means two of the side has to be equal. Similar to the previous problem, here from A I select a point B and point C which are of equal length. Here I am going to select a point B on third quadrant. This is our third quadrant and this is our fourth quadrant. I need to select the point B and C and third and fourth quadrant which are equidistant from the point A and B. So from the origin, if you are selecting a point on third quadrant, for assumption I am selecting -4 and -4. Here it's -4 comma -4. For instance, the point B which I have selected here is -4 comma -4, which means it is -4 units from x-axis and -4 units from y-axis. If I join these 2 points, I will get AB. Similarly, so the distance here made by these 2 points can be calculated by using distance formula. Okay, but that is not required here. I can assume that the point is located at 4 units on left hand side and 4 units on the right hand side. Similarly, I am going to select a point from the fourth quadrant which has to be of the same length. So on your right hand side, what are the quadrants are involved with the quadrant 4? That is your x-axis and y-axis, positive side of x-axis and negative side of y-axis. Similarly, I am going to select positive side of x-axis as the number 4 and negative side of the x-axis as -4. Suppose if you are selecting this point, then the point has to be 4 comma -4, which is of the same length from A, and the third side BC is here. Now this AB and this BC must be of same length, because when you calculated the AB's length and BC's length, it will gives you the same answer as this is like AB is equals to under root this minus this, 0 minus 4, it will be plus 4 whole square, plus 0 minus 4, again it's going to be plus 4 whole square. So answer is 16 plus 16 root 32. Similarly, if you calculated AC's length, again it is going to be 0 minus 4, it's minus 4 square which is 16, and 0 minus of minus 4, it's plus 4 square which is 16, which is nothing but root 32. See, yes, AB's length is also root 32, AC's length is also root 32. So these two sides are equal. So I can say that this is a isosceles triangle where one of the quadrant is in quadrant 3 and another point is in quadrant 4. So similarly, you can choose any point, but make sure that the x-axis length and the y-axis length which is there in the third quadrant and fourth quadrant has to be same. So suppose if you are selecting a point -7 comma 2, then same 7 units on the right hand side of x-axis with the 2 units on the negative side of y-axis, then it will give you the same answer. Okay, and the last problem number 9. The following table shows the points of S, M and T. In each case, state whether M is the midpoint of segment ST. When M is the midpoint of the segment ST, can you find any connection between the coordinate MS and T? So let's see. In the first case, they have given the point S as -3, 0 and M as 0, 0 and T as 3, 0. We need to check whether M is the midpoint of the segment ST. Okay, so what we are going to do here is I am going to find the midpoint of S and T by using midpoint formula. Whether my midpoint get matched with this point M, then I can say that M is the midpoint. Otherwise, it's not. Okay, so let's start our procedure with the midpoint formula. So midpoint formula is given by midpoint of 2 point is given by x1 plus x2 by 2, comma y1 plus y2 by 2. This is our midpoint formula. When x1 and y1 and x2 y2 are the 2 points, we have to follow this formula. Now I am going to choose the first case where S is -3, 0 and T is 3, 0. Okay, so midpoint of ST is equals to x1 plus x2, that is -3 plus 3 by 2, and y1 plus y2 is 0 plus 0 by 2. Minus 3 plus 3 anyhow it's 0. 0 divided by 2 is 0. Similarly 0 plus 0 is 0. 0 divided by 2 is also 0. So the midpoint of ST is 0, 0, which is equal to my M. The point M is also same 0, 0. So for the first case is M is the midpoint of ST. So the answer is yes, it is the midpoint. And the reason for your answer is midpoint of ST is equals to M. If it is not equal, then we can say that it is not a midpoint. So here it is equal, so it's the reason. And for the second case, point S is 2, 3 and point T is 4, 5 and midpoint of ST is equals to 2 plus 4 by 2 and 3 plus 5 by 2, that is x1 plus x2 by 2, y1 plus y2 by 2, which is equals to 6 by 2, 8 by 2. 6 by 2 is 3, 8 by 2 is 4, which is equal to our M in the second case, because M is given as 3, 4 and we are getting the same 3, 4 here. So this M is also the midpoint, and the reason is midpoint of ST is equals to M. The same reason we are writing it here. Okay, and in the third case the points are 0, 0. In the third case the point S is 0, 0 and the point T is 0, minus 10. Point T is 0, minus 10. Now midpoint of ST, which is 10, 0 plus 0 by 2, 0 minus 10 by 2. Okay, 0 plus 0 is 0, so 0 divided by 2. 0 minus 10 is minus 10 divided by 2, which is equals to 0, minus 5. But look at your M point here. The point M is given as 0, plus 5. But what is the answer we are getting here? As the midpoint of ST 0, minus 5. So this is not equal to my M. M is 0, 5. But here I am getting 0, minus 5. So they are not equal. And the question here is whether it is a midpoint, and the answer is no. No, this is not the midpoint. Reason is midpoint of ST is not equal to my point M. So that is the reason here. And for the last one, the point S is minus 8, 7. Point S is minus 8, 7 and the point T is 6, minus 3. 6, minus 3. So here midpoint of ST is equals to x1 plus x2 is minus 8 plus 6 by 2, y1 plus y2 is minus 7 plus 3 by 7 minus 3 by 2. So this is going to be minus 2 by 2 and this is 4 by 2. Minus 2 by 2 it's minus 1, 4 by 2 is 2. Let's check our M point. M point is given as 0, minus 2. Here we are getting as minus 1, 2, which is not at all matched with our M. M is given as 0, 2. 0, minus 2. 0, minus 2. Here we are getting minus 1, 2. So this is not equal. Hence the answer is no. This is not our midpoint. The reason is midpoint of ST is not matched with our M. This is the reason. So that's all about this video. In the next video, we'll solve the next 3 set of questions. Thank you, students.